Participants, kindly turn off your camera. Participants, kindly turn off your cameras, please. Turn off பண்ண சொன்னாதான் திருப்பி ஆரம்பிக்கும். Participant spelling என்ன?
P-A-R-T-A.
ஏவா?
P-A-R-T-A.
R-T-I-C-I-P-A-N-T-S.
Public technically complete physical college based monitor, pay, teacher and applicant are maintained.
Good afternoon to one and all. So, welcome again to the ATAL FDP of the day, session of the day. The resource person of the session is Dr. V. Karthigeyan, who is currently working as Professor in Sri Engineering College, he in EEE department. He has completed his BE degree in ECE from Dr. MGR Engineering College, ME degree in Applied Electronics from Anna University Chennai, and PhD degree from Anna University Chennai. He has rich experience in teaching an industry of 11 years and 13 years and 11 months, and he has got several funded projects to his credits. Besides, he has published more than 15 papers in Scopus Index journals, as well as some 50 papers in reputed conferences. Besides, he had participated as well as delivered several sessions in faculty development programs, and we are happy to have such a person here, as a resource person of the day. So, thank you very much for giving me the opportunity to give the welcome address. And now let me hand over the session to Dr. Karthigeyan sir. Karthigeyan sir.
Good afternoon, everyone, and it will be the end of our FDP session. And I hope you have gained so much knowledge towards your sensors as well as your actuators functionalities. And any like to congratulate the Theresa Engineering College Management as well as Principal Dr. George Clinton sir for their valuable contribution towards the successful running of their college. Now I would like to thank the coordinator of the FDP, Dr. Mr.Y.Palin Visu sir, their invite for inviting me as one of the resource person in this ATAL FDP, and I'm one among your colleague. My towards that energy scenarios in your wireless sensor networks as well as the how that harvesting it is utilized whenever you are going for a fog computing or a edge computing scenario. With me, small introduction. Now I am going to share my slide. So now. So this topic transfer to me energy harvesting in gradually towards the entering wireless sensor network, and a sensor network it is wireless one, and it is autonomously it is distributed, and they are for sending as well as the controlling and information collected using the sensor element. The sensor element will be temperature or sound or any measurement information. They are autonomously as well as distributively they are monitor as well as take the control measures what they have collected from the physical environment. So initially, before enter into a sensor, you need to understand what is mean by
sir.
Yes, sir.
Sorry for interruption. Your voice is not clear.
Is this clear, sir?
Your voice is not clear actually.
Sorry. Hello. Hello.
Sir, it is now clear.
Okay, sir. Okay. When we go for that ambient intelligence, many devices or autonomous devices they will gather that information and process the information from different sources, and they'll use or finally interact with the end users. That end user will say it is a human users, and they will be called as a attributors. Okay, so they will control that. They will based on the need of the attributors, that information will be collected from the physical environment, and based on the environmental information collected from the different sources, they will gather that information, and based on the information collected, they will implement the control actions. That will be conventionally we can say it is an ambient intelligence. When we go for your when we are going for a sensor network, details mainly consists of these things. We have sensing elements as well as the computing elements for your data aggregation as well as processing, and finally it need to be communicated to the end users, and finally the administrator, who is the attributor, he will ability to control as well as your we can collect the information without the need of their presence there. Okay, so there we can divide into your sensor network consists of your two main components. One is your administrator, another one is your environment scenario. The environment scenario is the one where we need to implement your sensor networks, or where we need to monitor or control actions that need to be implemented. That we can say it is the environment. The administrator, the attributor, we can say it is the user who is going to be benefited or who need the control action implementation. Either he may be a civilization, or it may be a IT sectors, in the industry sectors, or in a commercial scenario, or government entity, these people are comes under your administrator scenario. So finally, we can conclude your wireless sensor network. It is a group of sensor network. They will perform your distributed sensing operation. They will perform in a continuous manner. They will perform in a distributed task of performing either monitorization or you are collecting information from the open air medium. So what is the characteristics conventionally needed from your wireless sensor network? Should be a low cost, and energy harvesting is mainly mandatory when we go for your wireless sensor. That's why it is mentioned as a low power, and it should be a lightweighted because your deployment scenario, it may be a density deployment scenario will for that lightweighted mechanism will be a easy one to collect the data, and it has to withstand from the failures. That withstanding means that lifetime of the network, it is purely depends upon the sensors. So whenever we the lifetime of the individual node is increasing means that independently it means you are increasing the lifetime of the overall wireless sensor network. Conventionally, generally we can deploy your wireless sensors networks either in a random manner or a predetermined manner. When we intend to collect your information or monitorization of information, we'll put it in a random manner. But when we go for your security scenarios or your there we don't want to precisely mention where your sensor deployments need to be there in order to collect the information. Then we need to predetermine or that where your sensor is fixation, that need to be precisely predetermined. Overall objective is already I have mentioned where you can either implement for your monitorization or your information gathering or collection purpose or your finally control purpose application. Before enter into or before implement your wireless sensor networks, we need some preliminary or we need to perform these kind of scenarios. First one will be for large scale environment. When we intended to implement your wireless sensor network in a large scale scenario, then we need to conventionally we have to use dense deployments rather than your predetermined deployment, because your monitorization always need more and more amount of data. That data always needed a dense deployment of your sensors rather than your predetermined fixation scenarios. And sensing capabilities are based on once they have deployment is over, then the data need to be collected from that environment. The data collection either in that form of your distributed or a coordinated fashion. Distributed means individual node collected that information and it was central unit. But when we go for a coordinated session or a scalable, when we increase the scalability of the network, with the coordinated fashion only we are preferring. The collected data will be transferred, or with the support of your neighbors, it will be transferred to a central one. And when we try to implement some data augmentation scenarios or your data cleaning mechanism, then that need to be implemented in your intermediate sensor nodes, and these sensor nodes they will clean, and that localized algorithms will be implemented there, and data cleaning will be performed, and the clean data will be transferred to the end node of the particular central node of the particular network. And finally, one more need to consider, wireless sensor network need to be reconfigurable whenever that network failure will be happen, means the node malfunction is happening. The network need to be reconfigured themselves, and they need to get back they need to come back from that particular scenario, and they need to extend their working functionalities. And they need to provide a large scalability, or your coverage region or that lifetime of the network need to be somewhat more, and need to be withstand against some of the attacks, robust attacks. So when we implement your wireless sensor networks, these are all the characteristics that may affect your wireless sensor network's performance. That one meeting fault tolerance. So the sensor network that may affect due to interruption of your several here will be or scenario. So because of your sensor, we are prefer battery powered first nodes. So whenever that node is failure means that node will be out of the particular network. So it will be reduced one count for the lifetime of the particular network. Need to always make fault tolerances in order to provide a feasible or a efficient performance of wireless sensor network and scalability whenever you in your dense sensor network that coverage that radio transmission coverage that supported by the sensor network should be always high in order to provide a feasible solution to the application for the particular administrator who is looking forward from the particular wireless sensor network. And the hardware constraints always it is a lightweighted one, and we need prefer the lightweighted solution from the particular wireless sensor network. And sensor network deployment scenario as well as your topology, it need to be pre as well as post as well as redeployment scenario. Redeployment will be happen whenever your initial configuration is fully configured. They need to reconfigure themselves and they need to get back their original sensor network. The network is reconfigured and that overall application need to be continuously running without any degradation in the overall performance. In your sensor network performance, the environment is predominantly producing a major contribution in your in the particular wireless sensor network performance. The environment is the main thing because the data what we have collected from this for the sensor network to monitor or control application is from that particular environment what we have collected. So the environment is the crucial one. So the environment may be anything. Okay, it may be whenever we go for your wild animal identification or tracking means that wild animal, either it may be elephant or tiger, that will be called as one environment. Whenever we control or automate your remote health monitoring, in the remote health monitoring, that particular patient will be called as that environment. So environment will be a, because there only we have collected the data. Then transmission media, the transmission media, it may be a single hop or a multi-hop network. So there we have collected the once we have collected that information, that need to be transferred to the central node for the further processing. That need to be that communication, either it may be a radio frequency based one or infrared or an optical media will prefer for that communication in between your sensor nodes as well as your central unit. And finally, the important one, power consumption, because we the sensor mode will always that may be operating in an idle mode or in an active mode in a shutdown. Okay, whenever it is in a shutdown mode, it won't harvest any power or it will not utilize any energy. But when we will always prefer active mode of operation of your sensors, because once they have collected the data, that need to be transmitted. Okay, so for that purpose, active state is always preferred. But we could not entertain that sensor nodes into the ideal mode. Ideal mode is always wasting your energy. So you need to minimize your idle state as well as you have to entertain that or we have to maximize the utilization of your active as well as your off state in order to give higher energy support. So this is the thing I have initially given a more constraint, because the factor which is more influencing wireless sensor network is your environment. So environment, it may be anything. Okay, so here they have mentioned bottom of an ocean. When we are tracking, when we are collecting the information from about the submarines or your underwater creatures, and then the bottom of the ocean will be called as your environment. And when we learn about your natural calamities, that your tornadoes or your anything that may be a surface of an ocean, and home, when we implement your smart home automation or a large warehouse, whenever we try to implement supply chain management and industrial automation, that home or large buildings, we can say it is the environment. So conventionally, your environment will provide your data. Based on the data only, will either monitor or the control action will be implemented. So it is the conventional architecture of your sensor node. So mainly sensor wireless sensor network or a node mainly consists of these much of elements. So initially it may be a sensor or your actuator end. From the sensor we have collected the data. The control actions will be implemented in using your actuators. That everything need the controller as well as sensors need the power supply. That power supply here we are going to discuss the power supply mainly. The power supply need to be an energy harvesting one, that need to be regenerate your energy from either from the source or from the surrounding environment. And along with that we have a memory element to support your controller. Along with that we have a conventional communication devices in order to transmit the collected information to a central control. So this is the main components of a sensor node. Say it is a sensor as well as actuators, power supply, control, and memory as well as communication. The energy harvesting we are implemented into the power supply units. So energy supply, because when we implement dense deployment scenarios in your wireless sensor network, we'll prefer conventionally we'll prefer primary. It is a battery source, so it is not rechargeable one. Primary utilization. When we intend to use or increase the lifetime of that overall network, means we need to improve. We need to produce the battery or given the battery as a rechargeable one. So rechargeable one means that energy harvesting we can implement that may take energy scavenging. It is depends upon your energy sources around your environment. It may be in the solar cells or your temperature gradients or your MEMS elements, micro mechanical elements and nano mechanical elements, nano material elements, and along with that we have vibration as well as pressure. This much of mechanical actions that may introduce some energy. That energy will be utilized to restore the batteries what they have used in that sensor networks. So your wireless sensor networks will be classified into three categories. Either it may be a proactive network or in a reactive network or in a hybrid network. So proactive networks, it is conventionally used to periodically collect the data from the environment. So periodic data, they will turn on in that periodic interval, they will turn on that particular power supply and they will collect the data and transmit. Okay, in that remaining time, they will go for a sleep mode. And reactive networks, whenever they are implemented for a particular application, whenever when I have implemented one sensor for a temperature monitoring, and if it is the temperature, that quantity what is measured, that shows a drastic changeover, means that will be collected and informed to the control. That will be a reactive. That whenever that data what collected, that shows reaction means that will be collected and informed to the controller. Okay, that is of your reactive. So hybrid, it is a both combination, both reactive as well as your proactive approach. And conventional application, whenever the sensible data will always prefer hybrid. And the communication among your nodes, it will maybe a single hop or a multi-hop networks, and will prefer a multi-hop rather than your single hop, because the multi-hop implementation always increase the scalability of the network. Single hop networks, it is intended for your secure scenarios or that whenever we record a minimum delay related wireless sensor networks, then we prefer a single delay based operation. When we implement the multi-hop networks, intermediate nodes, your sensors will be act as a relay nodes. So this is the basic scenario of sensor networks, source as well as your sinks. Source always provide the data, that physical environment data what they have collected, and that will be called as a source. Sink, that need the data, that particular node needed the data what they have collected from the source. So then here we have mentioned different kind of sinks here. So the sink may be a one among your sensor nodes, or it may be a different among your data collection nodes, or your sink may be a somewhere far away from your distance. It will that through that your interfaces as well as your communication protocols, you are transferring the data to a sink. So your primary source will be a common one. That is no change in your sources, but sink may be anyone. Okay, so one among your one, or you are different from that initial one, or your collected sensor node, or it may be far away, farthest distance from your initial sensor. So here that we have mentioned a single hop as well as your multi-hop combination. When we intended for a large scalable wireless sensor networks, single hop networks always won't prefer, because the scalability will be very much poor, and when we try to implement a single hop networks, the energy harvesting is very much high. That the energy it will be very much the energy utilization is very much low, but the scalability is very much poor. When we intended for a multi-hop, we'll use a store and forward mechanism that data will be stored in the intermediate nodes, and then it is forward to the next node until it reaches to a sink. And we can say it is a collaborative network. So that intermediate nodes, with the support of your intermediate nodes, we can finally transmit our data to an end sink node. And difference that may be intermediate. The mobility that may affect your overall performance of your wireless sensor network. The mobility comes under three kind of mobility. One is your node mobility, second one is your sink mobility, third one is your event mobility. Node mobility means yes, relay node in between your source and sink that may take in the mobility, because of that the topology of the network is changed. So intermediate, where that particular mobility is taken before that predecessor node, that in that predecessor node the data will be stored. Once that structure is reformatted, then the data is forwarded. So because the store and forward mechanism is very much useful in that when the node mobilities happen. The sink mobility means whenever the sink, the particular sink, it is not part of the particular transmission, that may take in the mobility. So in between, in a shopping mall, there is a wireless sensor network we have created. Suddenly, one customer is entered into the mall and asking about the particular shop, or anything about that. Any beverages happen in the particular mall means that will be attended. He is also sink there, but the sink is not part of the already created wireless sensor network. That will be called as a sink mobility. So the sink is initially it is not part of the wireless sensors structure what we have created, but the sink may ask the data from the particular wireless sensor network. That we can say it is a sink mobility. Mobility where I have mentioned your environment may be a crucial role. Okay. So in that environment, we are detecting one environment that is taken mobility. Sometimes you are tracking one underwater fish. Means that fish will not always in a static position. So it may take it will take a mobility, because it is not in a permanent static position. It will move around. Okay. So we are detecting our submarine movement prediction. And here we have mentioned elephant detection. These kind of scenarios, what is the event we are measuring, or we are collecting the information that may take the mobility. So based on that, you are taking the sensor network architecture will be reformatted. So here one kind of your sink mobility we have introduced here. Here initially request will be generated from the particular sink. So the sources will collect the information and transmit to the particular sink. Here the sink is taken the mobility and move towards some other new position. Then the intermediate nodes act as a relay and forward the data to a final sink. So it is an event mobility. Here the event is a pink element. So pink element is initially detected, or the information is collected from the earlier RF environment. There we have mentioned as a circle. Here that now that the event is moving to a new position, based on that we have rearranged the structure, and now the information is collected from other three sensor modules. When we compare your wireless sensor network against your mobile ad hoc networks, So mobile ad hoc networks we cannot implement for your commercialization because it is highly intended for security applications or emergency scenarios where we won't consider the money, we will value the other persons or the environment. Okay, there we need to implement manets. Manets always prefer one-to-one connectivity. But when we intended for wireless sensor network, it is purely commercialization. Commercialization will be the predominant scenario in wireless sensor network. So it is multi-hub will be there, and your topology changeovers will be always crucial whenever we go for your wireless sensor network. And the environment is highly prone because we are using an open source RF environment. So that environment that may create some noisy or your second order effects to start to drop down the performance of your wireless sensor networks, but we need to provide the or gives necessary actions in order to access your MAC as well as your routing among your nodes to come from the particular failures and to work continuously for the intended applications. So these are, see here I have given some comparison about your wireless sensors as well as your MANET, and IP address is not mandatory when we intended for your sensors. When we intend for a minor range of application, when we go for your largest coverage with direct control, then we can implement it. So now I'm going to share some of the concept about your data gathering, dissemination, and aggregation among the sensor nodes. When we intended or placed the sensors in a deployment is happen, then the data will be collected from the individual nodes and transmitted to the central node. Okay, what is happening, how it is happening, that we will see in this slides. Okay, so it is a standard network scenario. It may be either in a client server scenario or in a publish subscribe scenario. In that we can collect your data, aggregate your data from the environment. Okay, so conventional thing will be it is maybe a peer-to-peer or a client server scenario. So it is this pattern the whichever that initially the request is initiated from the client side, then the particular server will provide the data. Okay, so whenever we implement your wireless sensor network, we need to consider only two things. One is decoupling, either in the form of your space or in the form of your time. So decoupling always need to be done in order to segregate your interaction among your nodes. So we can avoid the interferences. Okay. So this will be the initial scenario. So whoever collected the data, they will be called as a publishers. So once they have collected the data, they will, from their node identity as well as along the everything, they will share the data in a common bus. That will in that common bus, the particular subscriber, whoever intended to collect the data, they will collect the data from the software buses. Okay, so this will be the scenario, will be the simple scenario. So the buses need to be continuously active in order to collect as well as transfer the data among your publisher as well as your subscriber. So what are the variations this publisher subscriber model is? Either it is maybe a topic based scenario or in a content based scenario. So topic based scenario, it is not it is a straightforward application. Okay, so there is no changeovers will be happen, and conditionally that particular topic only will cover in the publisher as well as your subscriber end. So here one of the application we have implemented here, we need to verify what is the range coverage of the particular input. So it may give a multi-ordered verification system in order to finally track where the exact position of the particular system. So here the client server model is initiated. So client initially asked about what is the status of the particular data what we have inputted. So based on the conditional measures in between the sensors as well as your gateways, and through that we finally collected that position of the data, where it is fixing. So one more thing we need to we need to consider when we implement your data gathering is flooding and gossiping. So flooding is same data, it need not to be transmitted multi more time. Okay, here that node A collected the particular physical environment data. That information is transmitted to the neighbors. So here the data is flooded. The nodes what we have collected from the node A, he is better data what he is measured. But when it reaches to a single node D, the same data is repeating. Okay, so it may create so the manipulation of the nodes is wasted here. The same information will be reached to the end node. So we have to avoid the flooding scenario in order to give the energy garbage. Second one will be gossiping. So here the node A will provide the coverage of this much coverage. The Q will be mentioned as the coverage region of the A, and the B node will provide the coverage region of S. So based on the coverage, we can see that the intermediate coverage or the coverage region R that will shows the information that area information will be collected by both A and B. Okay, so that is not at all needed when we try to implement your wireless sensor network. So we need to avoid your overlapping of your areas coverage. That same area information need not to be covered from in the two sensors. So that also we need to avoid. So in flooding, we have a each sync node and you're gossiping your number of duplicate informations among your particular area. Same area that may produce two or more sources will provide the information. So these things need to be avoided when we are implementing your sensor. So to avoid that, we are using that wireless sensor in your wireless sensor network. They are using a spin protocol. This is for your data gathering as well as your dissemination. This is for your data gathering as well as dissemination applications. So it is based on simple scenario. So here the data negotiation as well as resource adaptation will be happen, and initially the traffical nodes will avoid your data. Data will be shared the particular node who is shown some interest. Okay, so the spin protocol working is very much simple. Once the data is collected from the particular end node, he will put an advertisement. Okay, so he will put the advertisement about the new information. Whenever the node is collected a new information, he will put an advertisement. Once that advertisement is reaches, then the node who is intended to collect the data from the particular advertisement, they will send a request. Okay, so based on the request, he will share the information. So the flooding will be avoided here. So flooding of information, we won't transfer the data to each and everyone. Whoever interested, they will put a request and they will collect the data from the particular advertisement. So the spin protocol drastically reduce the flooding scenarios in your wireless sensor network. So here some of your spin examples I have mentioned here. Once the node is collected a new information, he is posting an advertisement. So for that advertisement, the node who is intended, they'll send a request, then we'll transmit the data to the intended node alone rather than for the every nodes. The spin, we have a different variations will be there. It is maybe a point to point, or it may be a threshold oriented, or in a broadcast control. Okay, broadcasting will transfer to everyone in order to increase the scalability. And your threshold means we'll measure that energy level of the particular neighboring nodes. If the particular request is received from the feeble nodes or the nodes which is having a minimal energy level, it cannot able to rebroadcast, means we won't transfer the data to the particular nodes. We'll based on the energy constraints or your resource availability, will transfer based, that will be called, that will be the second scenario. So threshold based will transmit the information. So initial one, it is a point to point. So that is the advertisement request and data data transmission. That scenario will be spin point to point. So it has some pros as well as your cons. So pros will be the internal node alone they'll collect the data. So energy consumption, it is always very much improved, and flooding will be very much removed here. And and the cons will be advertisement as well as your request. These will be called as your controls. Okay, the control informations are implemented in order to transfer the data among your sensor nodes. So that is of your spin, and the second will be of your directed diffusion. So directed diffusion means it is a data centric approach. So here the data will be the predominant source and predominant one. The data need to be reached to a sink rather than we need to consider individual nodes. Okay. So request, whenever the request is initiated from the sink, and the source will satisfy the need of the sink through the routing of your data. Okay, that is of your directed diffusion. So here the data need to reach your destination sink from the directed path from the source, and we have to localized. It may be create some sensor network that may be a topology transformation that may be happen. Means we need to locally restore the data and retransmit unless and until it reaches to a sink. So it may always consider multipath delivery of your data. Always we won't depend upon a single path. It may take a multiple path in between the sender and the receiver. So in your directed diffusion, these are all your key terminologies. Initially, interest will be generated from the sink. The data what we have generated from the source that may reach to a destination with the reinforcement scenario. Reinforcement, we are learning from the back and past and previous environment scenarios. Based on that, they will forward the data to reach the sink. So here is the best scenario among for data transmission applications. So here that query is in the direct diffusion, we can mention that what rate we needed, or we can mention packet what we have initially transferred towards this from the source to a sink. Here that query they have mentioned what is the delay, what is the time duration that need to be mentioned. Okay, so it is one kind of example. So it is the directed diffusion. So initially sink that need to know what is happening about your source. So he is sending. So he is shown some interest, and the interest will be forwarded. Once the interested reaches to a source end, he will transfer the data. So he will transfer the data in a shortest path. Okay. So through that shortest path, it may reach to a destination. So in that path, sometimes it may that intermediate relay nodes that I have mentioned, node mobility that may happen. Okay. So node mobility happen means that particular node will move from one place to another place. Based on that, the topology change means that information may lose. Okay. So finally, it's in the pipeline. If the particular node is not responding, we have a multiple path in between the source to sink. So it may take another path to collect the data. So that is the main thing of your directed diffusion. It won't it won't depends on a single path alone. So that is the advantage of your directed diffusion. So it is based on the demand. Your information, so source will collect the information and transmit to a data. So it is a data centric approach. Your data will reach to a destination in in dissemination as well as your reinforcement scenarios. So it is queries need to be reached to a source end. If the query is interrupted by some other attacks, means that data will not deliver to a sink. That is the disadvantage of this mechanism. So data aggregation scenario, here the data aggregation, all the nodes are collected and finally transmit to a end node. So this may happen, or it may that collected information, it may have it will transfer a multiple hop to reach a sink. So these may also happen. So data aggregation always related some of your performance metrics, initially accuracy. So whenever we collected the data, how far the value matches or accurately measured from the physical environment, we can say it is accuracy. So all the readings need to be reached to a destination end, we can say it is a completeness and latency. Delayed data will be treated as false data. So whenever we need for your card real-time system applications or your industrial automations, the data collection need to be completed in a shortest span of time or in a within a minimal period of time. So the data what we have collected beyond that interval will be called as a falsy data, because that data will not be employed for the automation applications. Okay, so the latency need to be maintained within certain limitations, and overhead among your sensor node need to be minimized, because that wireless sensor network, each node has to support your neighbors. Okay, so whenever your overhead is increasing means the node will not support for the neighbors. So it is the aggregation request. It is a simple database oriented aggregation request what conventionally it may generate from the individual nodes. For the example I have shown here. So based on the attributes what they have collected, that shows some aggregation. For individual epoch it has run. So periodically this epoch is run and collected aggregation data. So aggregation operation category, it may be a duplicate operations or a summarize that application. Duplication always it may be a statistical operation. Any one of the statistical operation is performed on the collected data, and finally it will be transferred to end. And the composable data, it may be always consider either it is a functional oriented service. So function, we can define your own function. The G is either you will define your own functionality. It may be a max or min, all your final that your average function or that functionality, based on the functionality what you are defined for that composable, that will run. So initially we need to locate where the particular sensor node, based on that only your we need to provide your energy harvesting as well as your routing, everything. Okay, so we need to precisely locate your sensors, then only we can implement energy harvesting, because we don't whenever we couldn't identify the where the particular sensor is deployed means we that routing or your MAC allocation, everything will be vain. Because it won't reach to a particular end node what we are intended. So the location discovery is very much mandatory. So location discovery, either it may be depends upon your physical position or your logical location. So physical position, it is purely a coordinate system what before based on the known coordination systems what we have in that conventional environment. Based on that, we need to identify where the particular node is. Okay, so option, it may be a centralized one or or maybe a distributed one. So it sources of information, it may collect the data from the either from the indoor environment, from the outdoor environment, or in a global way. Metrics, we need to consider the accuracy, precision. Finally, we need to along with the energy harvestation. So initially, first approach or the conventional approach will be from the information source, we need to measure where the particular node is available. So we need to find out the coverage region or the proximity where the particular node will provide that one. So temporarily we'll send the data to the particular node. Based on that data collection as well as reception, we'll identify the location. Okay, that will be a proximity based scenario. Second scenario will be an angularization based scenario. Here trilateralization will be used. There you are need to place at least three sensor nodes. That position of the nodes is identified, or we have already known the location of the node. Okay? So we need to place the nodes in such a way that unidentified the node is in between or intermediate in between the particular nodes. Based on that, we will collect the position of the sensors. Okay. So trilateralization will be the best scenario because your that accuracy precision level is very much close. Sorry, precision is always very much high when we go for your angularization. So scene based scenario will, based on the past as well as your previous information, will track the position. So we can estimate the position of the sensor based on four scenarios. First will be estimating the distance. So it is initially based on signal strength. So we'll send a known signal of strength, and that particular node will collect the data, and they'll respond based on the received power. What they have received power, we will find the distance d. Here the d is depends upon the factor c and alpha. C, we already know that light wave propagation, and alpha is your path loss coefficient. The path loss coefficient values is vary from 2 to 4. Okay. So for the conventional environment, we are considering only the reflection alone, means we need to consider 2. When the environment scenario is highly critical one, then we need to increase the path loss coefficient up to 4. So based on the known signal strength, we can measure what is the distance from the particular sink from the source. So you can find the location, where the precise location of the particular node. And second will be time of arrival. So here we are transmitting one signal. So we are waiting for the particular signal to receive. Based on the arrival, time of arrival, we will collect the, we will measure the distance among of the particular node. But the synchronization among the node is mandatory for this one, because the particular node has to respond whenever it reaches the particular data. So the synchronization is mandatory here. And third one will be time of arrival among different nodes. Okay. So here from the source will transmit two different propagations. Either it may be one will be RF, and here they have mentioned one will be RF propagation, another one will be ultrasound propagation. So once we have collected the received data, we will find out the difference among the received signals. Based on that, we will find out the location. So here I have mentioned the determination of angles. The angles may be different. Angle differentiation, we can use the directional antenna. The directional antenna, it may be physically they may rotate, or we can use your electrical properties. The electrical properties will be turn on for a particular location, particular side alone. There we can provide your directional antennas. Okay. So we can rotate, or we can provide the angularization commands. So initially we need to find out, we need to form a triangle that I have mentioned, approximate a triangle in such a way that the unidentified, the node we want to place or find out, that need to be in between the particular known positions. Okay. So this, the right side one, we cannot use for your trilateralization, because the unknown node is not in that is not in that particular coverage of the particular triangle. Okay. So once you know the known position of these 3 points, we can finally find out the exact position using this Pythagoras theorems. So using the trilateralization equation, this is the final equation: 2 times of x3 minus x1, x1, y1, x2, y2, x3, y3. These three, the premise or predefined location that is of the triangle will form. So from within the triangle only, that unknown node need to be there. So based on the information, we can find out XU, unidentified location, that node location we can find out. So sometimes that trilateralization that may show some error, means we have to add some norms values. And norms, either L1 norms or L2 norms is added along with the overall functionalities. Whenever the norms values that shows a minimum error value, means then that shows a precise location information. So now I am entered into a core topic of our topic. So sensor node is purely depends upon the lifetime. So lifetime need to be improved, means the energy harvesting is very much mandatory. So energy harvesting can be implemented in various ways. Okay. So initially energy aware MAC protocols we have implemented, that is of your spin protocols, as well as your leech. in the routing using a leech based routing, and duty cycling means the duty cycle always on time divided by off time, on time divided by total time period. Whenever we need try to implement a minimal duty cycle means that may always lengthy remaining period we can utilize for your restoration of your energy. Okay, so your low duty cycle preferred when we intended for your wireless sensor network application, and the sensing rate is adaptive, and we need to provide a redundant nodes rather than depend upon the individual nodes. Okay, so the performance cannot be, we cannot optimize all the parameters what we are intended for the wireless sensor network, because we are directly operated on the environment. Okay, the environment conditions also create some disturbances, or that may affect your overall performance of the wireless sensor network. We'll see what are the hurdles that need to be taken care when we use your wireless sensor network in a physical environment. Initially, high battery capacity we are expecting. Because the battery capacity in high means that overall lifetime of the network is high. So, but when we try to implement that, the cost of implementation is it is increasing. Okay, that I have mentioned, when we improve your energy harvesting, we have to use low duty cycle. When we use low duty cycle, but that sensing reliability is very much poor. And third thing, higher transmission range. Higher transmission range means your scalability of the network is very high, but the higher transmission range always require high power. High power always minimize your energy harvesting scenario, and lower transmission range that may that will improve your energy harvesting scenario. But when we use that is between your source and sink, we are fixing a lower hops means that may take a multiple hop to reach your destination. So these are all the things. If you are considering one thing, the another parametric that may end it in a poor metric. Okay, so we need to consider everything, and we need to achieve your final energy harvesting scenario. So here I have mentioned some of your energy harvesting scenario in order for the final wireless sensor network, or in a e-hub network. So either you can take from the source, or from the particular human or particular event. From the event itself, we can collect the energy and restore it, and we can reboost their overall wireless sensor network. So here some of your energy harvesting scenarios I have mentioned. So from the human activity, we can, or from the human activity or from the environment, we can harvest your energy, or your conversion of your energy from one form to another form. We may create some energy, light to a heat, or heat to a pressure to a electrical voltage. Anything can be one form of energy conversion. Okay, so that may create some energy that we can use for your restoration purpose. And information communication equipments, RF transmission also produces some energy. That energy also we can employ for your energy harvesting. Okay, so energy harvesting architectures, either it will be in the two way: harvest as well as your use scenario. Harvest, store, and use scenario. Harvest scenario, from the source, the energy harvesting is taken place. Then finally it is deployed to a network. The sensors work whenever that it will be act as a power supply. Okay, harvesting system directly provide the supply to a sensor node. So sensor node will work on that, and some of the thing will be, some of all the harvesting power will not be utilized for your sensor application. Some of your power will be waste here. Okay, to avoid that, your harvesting system will store the power either in a primary memory or a primary storage device, or in a secondary storage device. Whenever the sensor node is needed the power, that may take the power from the storage devices. Okay, so that will be of energy stored use. Here we can, from that application, we can see that the lifetime of the network is very much high when we go for energy based on the store and use scenario. So your harvestable energy sources from the physical environment sources only, we are mostly collected that harvesting energy. So it may be a controllable one or an uncontrollable one, or a predictable one or in an unpredictable one, or in either in maybe ambient source or in a human power source. Okay, so we'll see one by one what is controllable, non-controllable, predictable, unpredictable, ambient, as well as another thing. So some of your energy sources I have mentioned here. Initially it may be a solar, or in a wind, or in a footfall, or in a blood pressure scenario. So solar, in that solar panel or a solar cell will be act as a energy conservation mechanism. That your characteristics, your energy harvesting scenario, it is very much low. It is per centimeter square solar cell, it may create 15 milliwatt. And that controllable type is either it is uncontrollable one, because your solar, it is purely taken from that sun. Okay, so it is unpredictable, as well as the uncontrollable one, because the energy what you are received from the particular solar, it is solar cells, it is directly depends upon the sun rays. Okay, so whenever that is a wind, that is a cloudy season, we cannot able to generate that much of energy from this particular conventional seasons. So when we go for your wind day scenario, it is an ambient, uncontrollable, as well as predictable one. It can generate a bulky amount of your harvesting, and per day it will be generate 1200 milliwatt. And footfalls, it will be the local action of your human, and based on the human actions, we can generate the power up to 5 watt we can generate. It is a DC one. Okay, so it is a blood pressure, it is a human power. But here that blood pressure oriented things we cannot, we didn't implement it in the wireless sensors. Other things they have verified with the wireless sensors. So now the sensors will be replaced with the harvest sensor, energy harvest sensors. So conventional sensors, they will collect the data from the physical environment, and they will transfer that into a controller, and through the low power transceiver they will transmit. So from the lower order thing, we will add it to the upper layer. So the energy harvester, they will harvest the energy from the physical environment. So they will store the energy either in a primary, in a secondary storage, and whenever that power is needed, that the processor which is available in the sensor, they will utilize the power and increase the lifetime. Okay, so now your sensors node, a E-hub node, we can say the E-hub node is the contain these much of elements. So these table shows some of the storage technologies. Always we mention wireless sensor network will be operated with the battery powered source. Okay, the battery. What are the batteries we can use, and what are the maximum capacity or rechargeable cycles they have mentioned here. And the first one will be of your SLA battery. It is sealed lead acid battery. So it is nominal voltage. The voltage is 6 volt. So it will be that battery is either operated in a trickle mode or in a pulse mode. Trickle modes means will transmit a low power, that will be operated in a low power, but it's in a continuous level. Okay, low value continuously storing means that will be of your trickle. When we go for your pulse, we'll supply a sudden current in a minimal duration. So your trickle will be take a lengthy duration, but the current value is minimal. But when we go for your pulse, the current value is high, but it will be happen in a minimum duration. So these batteries only will they are utilizing in your wireless sensor node. Initially it will be sealed lead acid, and second will be nickel cadmium, and third will be nickel metal hydrate, and there we have seen lithium ion batteries as well as lithium polymer batteries. We have seen so much of our applications. Okay, so these batteries only they are utilized in your wireless sensors for the energy harvesting scenarios. So these batteries either operated in a trickle mode or in a pulse mode. So what is the application of your energy harvesting sensors as well as your nodes means? So we can extend the applications to somewhat extended. The lifetime of the network will be increased. So also we can increase the scalability also. These are all the sources I have mentioned. It is maybe the harvesting. It may be happen from the solar or from the working of the sensor networks. Also, we can generate your power. That will be active user power. and wind energy, RF energy. Active use of power, either it may be from the administrator level also we can regenerate your energy. So we'll start one by one. Solar energy harvesting systems. So solar energy harvesting systems will be classified into three categories: nodes with the battery based storage, node with the supercapacitor based storage, node with the tired storage. Okay. So supercapacitor based storage will prefer because it shows a much more improved performance rather than the other two categories. So initially it will be a supercapacitor based approach. So initially we are applying some external power supply. So the active elements will be regenerated in the in between gaps. So based on the movement of your active materials, that may create some energy. That energy will be stored and that will be utilized for your batteries. So this is of your supercapacitor approach. Okay. So we'll come so one kind of application we have mentioned here. We are comparing battery based supercapacitor as well as your hybrid approach. So initially battery based approach that is applied to a hydro watch and helmet as well as fleckle. Fleckle is we can say it is a tiny wireless sensor node that will be implemented to collect the physical environment data. Okay. So hydro watch, it is implemented for your water related data collections, and from the water movement itself they will collect the energy to restore back. Okay. So hydro watch they will implemented there and they are generated at 277 milliwatt. This will be employed by the particular author in the 2024 application. And heliomate they have developed up to 190 milliwatt. Fleckle that not at all given that much amount of initial power so from the solar, but the final end solar capacity, battery capacity, it will withstand up to 2500 milliamps. So here we will see the comparison of super capacitor based approach. Here we will see Everlast solar biscuit as well as your sunflower based scenario. So sunflower pin diodes combination along with the solar panels are implemented for your energy harvesting scenarios that can withstand up to 20 milliwatt energy harvesting. But the solar biscuit and Everlast scenario that shows a greater performance rather than your solar biscuit. And tired storage. So here the combination of both the thing we are implemented. These scenario only will prefer when we go for your event tracking application. That event is taken the mobility means we'll either use Prometheus or your Ambimax scenario. So here Prometheus or Ambimax will prefer pulse based triggering scenario. Pulse based means lithium ion or your lithium polymer will be employed in the battery in order to restore your work. Okay, storage type we have mentioned here. So either we can use battery based or your supercapacitor. So solar energy harvesting, here these are the comparison. Nowadays we'll prefer more and morely pulse based scenario. So pulse based scenario they have implemented in Zebra net, Turtle net. These are all the net they have implemented to track the particular zebra or in a turtle or in a triode nodes. Once 3 nodes are implemented to collect the data from the particular node instead of a single one. In a particular place, 3 nodes are placed and to collect the information. Okay, that is of your trio nodes. And hydro watch, we'll see one by one. So it is a first one, zebra net. Here the particular node, wireless sensor node is placed on the neck of your zebra. It will track the movement of the particular zebra. Along with that, it may say it will perform the energy harvesting that we will see here. So it is a sparse network. It will track the movement of your zebra and continuously give the GPS information about your particular habitats. It may be a zebra or anything. We can put it the particular. We can we have to place the particular node in the neck of the particular event what we have to track. Along from the zebra net, it have a 14 solar modules we have attached. In that author they have implemented. So in that 14 solar cells, they can regenerate the power up to 7 milliamps. Okay, so based on that, they have improved that lifetime of the network up to 2 to 3 months, increased lifetime. So in the Zebra net, they have implemented a lithium-ion battery. So lithium-ion battery along with the supercapacitor approach, they have implemented to improve the lifetime of the network. So second one will be of your turtle net scenario. Here the turtle movement, along with that, we have verified, we have implemented the energy harvesting. So in the turtle net, e-flux node we have generated, flexible node we have implemented there, and in that they have a rechargeable battery of 90 milliwatt they have generated that. So these nets we can implement it for a tracking of your element, particular animals implemented. So in that same way we can use for your wild animal identification as well as tracking. We can anything tracking will be happen along with the energy harvesting also we can implement. So this is the third scenario, trio node. So we have seen here, instead of in individual node, trio nodes will be placed, and from the top position we can place the particular trio gateway. Okay, so in the trio trio nodes will collect the information and send it to a gateways. In that gateway we'll place the solar cells to in order to provide your energy harvesting scenario. So multi-tracking. Each sensor will cover a different position information. So multiple information will be collected in a particular node, and it will be informed to a central cluster. So in that cluster we have to implement the energy harvesting scenario. So next thing will be of your shimmer. So it is a flackel based scenario. Flackel, I have mentioned, it is a tiny one, and tiny supercapacitor based approach they have implemented there, and it will always use a minimal power. So either we can use nickel metal hydrate or your lithium ion based battery sources for your shimmer applications. So this application, it is used to verify the structural stability. Okay, from the structure, civilized structures, we need to verify what is the quality and what is the lifetime of the particular civil structure means. Then we need to use shimmer. So they will perform the sensing actuation and from the particular civil structure, and then they will inform to a centralized node. So other than that solar based scenario, we have a photoelectric based harvesting and shoe powered out of attack system and wireless self powered push button controller also available. So in a piezoelectric effect, piezoelectric means one form of mechanical energy will be converted into electrical energy. Here we are converting from mechanical force into a electrical quantity, and finally we'll store it in the battery. Okay, so either we can use PVDF, polyvinyl fluoride, or lead zirconate titrate, PEST material. So these material will convert your mechanical into a electric. So photoelectric based harvesting. So PVDF, initially we will compress that particular PVDF or your PST material. So that will create some electrical energy. That energy will push to and that apply to a battery for harvesting scenarios. So once that harvesting is happened, then that harvesting will be utilized for the future applications. So that will be of your for initial one. It is a shoe powered RF test system. So in that RFID tag will be put it in a particular shoe. So whenever you are pressing the particular shoe means, that may create 12-bit identifier code. That identifier code will transmit over a short distance. That whenever that transmission, that particular signal is generated, means from the generated signals we can harvest the energy of 2 millijoules per step. So we can, rather than PVDT, here PEZT materials will be highly employed. This energy harvesting scenario will use when we employed for the particular humans. Wireless self-powered push button controller. So this controller is not implemented in a wireless sensor network, because it need a manual push for the generation of your energy harvesting. So we have a push button. Whenever we are pushing the particular button, it will generate a 12-bit digital code for up to 50 feet. So based on the code generation from the signal strength, will the energy harvesting will be happen. But it is not shown a improved performance in a sensor networks. So other than your conventional harvesting scenario, we can implement wind energy harvesting as well as RF energy harvesting. Wind energy harvesting, that we cannot try, we that always need a space. We need a predetermined location for the energy harvesting scenario, because that shows us a minimum, that implementation always needs some space. So because that is that I mentioned. Okay, so size of the wind as well as the turbine issue. So we need some deployment, predetermined set deployment is needed when we try to implement your scenario. Radio frequency always needed an intruder. Based on the intruder only, it will generate the energy. Okay, so these are all your future work. They can implement in the futures. So implications, energy neutral operations as well as performance adaptation need to be improved. So overall, we need to provide a node level as well as your application level improvement in the wireless sensor network. So node level adaptation, either we can improve in a low duty cycling or a transmit power minimization or a sensing reliability improvement will be need to be improved, and we need to schedule your sensor nodes to improve the active operation of your sensors. So network level operation, either we need to improve initially from the data collection to a routing to a clustering. We need to implement energy based scenarios rather than your other resources. We need to mainly concentrate on the energy as is a main resource. Based on that, we have to work. So here I have mentioned some of the routing scenario. Traditionally, we'll always consider latency oriented or a bandwidth oriented routing. Here we need to consider a power oriented or a energy oriented routing. We need to consider active energy saving, and we need to always use the energy in a efficient manner. Efficient energy utilization based routing we have to prefer. Okay, so that will always active your energy saving, and your topology control need to be done, because your topology failure always produces data loss that may give energy loss also. Okay, so routing mechanism always need to be done, that I have mentioned. So you need to prefer your routing in a first hop or in a second hop and a full hop latency. You need to initially verify. Based on the latency, the power level will be initialized. Okay, so least latency path. When we prefer for a sensitive data transmission, we need to prefer that latency among your nodes need to be minimum. For a non-sensitive data, we need to prefer energy rather than latency. We have to prefer energy. For a critical as well as sensitive data, we have to go for a multiple path rather than for a single longest path. So here I mentioned clustering based scenario. The clustering, either a leech based or a S leech based scenario they have implemented. So S leech means a sectored leech. So initially you have to find out the cluster heads. So based on the cluster heads, we have to route the data packets to end-to-end nodes. Okay. So based on that, we can harvest the energy up to 10 to 45%. So S leech, that shows a greater improvement in routing. So data collection, we have to implement MESW application. Here MESW stands for your monetization, energy, scalability, as well as your wireless communication. So these among all the four things need to be energy constrained. If all the four things are energy constrained, we have to achieve the overall requirement of the particular network. So based on that, MAC may be a BMAC or in a LMAC or in a XMAC. BMAC is your Berkeley MAC, and your LMAC is a lightweighted MAC, and your XMAC is a low power utilization MAC. So you can use either three of these MAC along with the preamble to minimize the energy harvesting. So finally, we can achieve the minimum active period and high sleep period among your sensor nodes to improve your harvesting scenarios. So this will be the overall final thing. So energy either we may harvest from the in the form of your energy sources that is available in the environment, from that environment collected the energy source that will be conditioned and managed and stored in a primary or in a secondary supply. From that sensors, they can utilize that and they can increase the lifetime of the network. Okay. So these are all the future. Future is researches is still going on towards your energy harvesting scenario. This is in the windmill scenario, and it is in the uh, within your RF board, within the motherboard itself, they are providing your energy harvesting. So with the energy harvesting scenario, will increase and improve the overall performance of the network with greater accuracy as well as your precision among your sensing environment. Okay, with this note, I'm concluding my topic today. Okay, thank you everyone for your patience. Thank you.
Yes. Happy, sir. Thank you very much.
Thank you, sir.
Can you recognize me?
Yes, sir.
Okay, thank you,
Triply
sir.
Professor Vana.
Thank you so much. Thank you, thank you.
Thank you,
Participants,
sir. Thank you.
is there any queries? Kindly put it in the chat box. Participants, do you have any queries? Means kindly put it in the chat box.
Once again, thank you everyone for your patience.
Thank you, sir. Thank you, thank you.
Thank you, sir.
Participants, I request everyone to type your feedback in the chat box, please. அந்த ஒரிஜினல் எடுக்கொண்டாங்க அந்த ஒரிஜினல் எடுக்கொண்டாங்க ஃபுல் ஸ்க்ரீன்லேருந்து எடுத்து எஸ்கேப் பண்ணலாம். Participants, kindly put your feedback in the chat box. Sir, actually, feedback link will be provided during the valedictory session today. So, thank you. Is there any feedback? All participants are requested to type their feedback in this about this session. Thank you all providing for the feedback. Sir. Participants, next session will start at 3:45 p.m. So kindly don't leave the call. The resource person will be coming by shortly. Thank you. Sir, actually, starting, the exam will start after the session is over. The two sessions are over. Sir, attendance we will update today or tomorrow. Okay, sir, we will do that. Within 1 week, you can receive your certificate. Okay, sir. Thank you. Test will be after the two sessions. Today we are having still further two sessions are there. After that, immediately after that will be test will be conducted. We will post the link in the WhatsApp group. Thank you. Shantini ma'am 80% of attendance is mandatory. Kindly take a note of that. Participants, kindly turn off your camera, please. Sir, immediately after the second session is over, as a assessment time, sir, it will start by 3:45 p.m. as we announced the earlier. It will start in few minutes.
Sir, what time, sir? 3:45 it will start.
So second session will start at 3:45, sir.
Ma'am, the resource person is actually coming. Good evening to one and all present here, and we are happy to start the session before the last session. This session will be handled by Dr. Karthikeyan, Associate Professor, St.Mother Theresa Engineering College, Thuthukudi, Tamil Nadu. He completed his UG in the year 2002 in Electrical and Electronics Engineering and PG in Power Systems in the year 2005 and completed his PhD in the year 2019. Now he has a rich teaching experience of 20 years and he has published more than 40 papers in Scopus journals as well as reputed conferences. To his credit, he has 10 patents in his hands. He is active in fetching more and more research funds for the institution. So we are happy to have him as a resource person of the session. Now I hand over the session directly to Dr. Karthi sir of St. Mother Teresa Engineering College. Thank you.
Good afternoon. Welcome to my presentation on sensor calibration and testing. Today I will explain the importance, methods, and real-world applications of sensor calibration and testing. Let's begin. Now I open my PPTs.
Sir, is it not connected?
Sir, kindly wait. The session will start.
sensor calibration and testing. Sensor calibration is the process of configuring a sensor to provide measurements within an acceptable range of accuracy. Over time, sensors may drift due to the environmental conditions, mechanical wear and usage, and making periodic calibrations essential. Here, testing verifies that calibrated sensors function correctly under real-world conditions, ensuring consistency and efficiency, and also the compliance with the industry standards. So, the sensor calibration has to an important contribution in industries. What you learn in this session. First thing is importance of sensor calibration, real-world consequences, calibration methods, industry standards, calibration for various sensors, environmental impact, automation and IoT, error types and testing protocols. So first thing I explain about why this calibration is very important to our industry. In real-world incidents, highlighting the importance of calibration. NASA Mars Climate Orbiter. In 1999, NASA sent an climate orbiter satellite to the Mars to check its climate of the Mars. Here, what happens means a calibration error in the unit conversion caused the spacecraft to deviate from its intended trajectory, leading to its destruction. So, particularly, what are the things has happened? We have to analyze, and I would like to explain this. So, actually, what happened means there are two teams worked in that work. So, one is used and one units, imperial units, and another one is they are used and another type of units. So both has been source in different direction to the orbiter. So because of that, the orbiter changed its direction and but directly on the Mars it has been destructed. So this is the problem in that. So two teams worked in different direction and they used in different units. So because of that, the orbiter landed in a different direction and destroyed in the Mars. And another one is 3 Mile Island nuclear accident also has happened in 1979. So what happened means, and faulty sensor readings contributed to the partial meltdown, emphasizing the need for the precise calibration in critical systems. So faulty sensors readings also an important things. So here what happened means one sensor is doesn't calibrated properly. So because of that, in a nuclear accident has been happened in 1979, and another one is overdoses in radiation therapy. In several cases, miscalibrated equipments led to the radiation overdoses in patients, highlighting the importance of accurate medical calibration, device calibration. So what happens means radiation therapy. If we are giving the overdose of the medicines or the overdose of the radiation on us, it will lead to an higher level radiations max the body cells and cancers. So because of this, we have to change. We have to check the devices calibration. Next one is pipeline failures. Pipeline failures, pressure sensor inaccuracies also has happened, have caused pipeline bursts, resulting in environmental and financial damages. So this is because of pressure sensors. This is because it happens because of the pressure sensors. So it happens in industries and causes the very damages on the devices. And next, aircraft incidents, incorrect airspeed sensor readings also contributed to aviation accidents, enforcing the need for rigorous sensor testing and calibration. So incorrect speed sensors readings also killing the peoples. So this is very important. So these not only these incidents. So there are lot of incidents are happening day by day because of the improper calibration of the sensors. Next, principles and methods of sensor calibration. Methods. What are the methods are used in sensor calibration? First one is zero calibration. Second one is pan calibration. Third one is 2-point calibration. So what are they? First one is zero calibration, adjusting the sensor output when no input is present. Second one is pan calibration, adjusting the sensor's response at a known input value. Third one is 2-point calibration, using both zero and pan calibration for °C to ensure its read is correctly at both extremes. So if you are going to sensor, you are going to calibrate and sensor means first you have to check in 0°C and also for 100°C. The here boiling water means all people can know and will come to know about is 100°C. It will be a known reference values. So in both extremes, we can identify what are the calibrated value. We can easily identify that one. Next one is importance of sensor calibration in industrial applications. There are a lot of industrial applications are used in, by using sensors. So this calibrated means it will make the sensors will be more accurate way. So for example, pressure sensors in an oil pipeline must be calibrated to prevent leaks. If the sensor reads too low, it might not detect dangerous pressure levels, risking an explosion. So not only explosion. Standards for sensors. What are the standards are used for the sensors in industries and evaluate what they are using? There are three types of standards they are using: primary standards, secondary standards, and working standards. So first one is the most accurate and traceable standards, like a standard particle distance thermometer. Second one is secondary standards, less precise compared to primary standards, but more practical for routine calibrations such as calibrated thermocouple. Next, third one is working standards, which is used daily usage. Particularly, I would like to explain about this one. Yes, these standards, particular these standards are using, but day to day, what kind of standards we are using means working standards only, because working standards means we may not have an perfect readings in our parameters in our day to day. For example, I would like to say about if you are going to an vegetable shop, they will check the values, how much kg for vegetables, how much kg for rice, and how much kg for other goods like an banana, like that they will we have to buy. So but we can use it the measurements, the devices which are using for this kind of the checkings. We are using that standards we are using, but we can't particularly say about that how much kg is being particularly checked through this one. We can't say that particularly means if it is for 1 kg means 1000 grams must be there, but we can't ensure that one that is being a 1 kg, because sometimes it may be a 950 also. So if it is being like that means we won't worry about that. But if we are going for an jewelry shop, if you are yeah, for 8 grams means 8 gram is 1 pound right now. So what is the value means it may be an 7,000 to 8,000. It will be there. So, but comparatively, if we are losing an 8 grams means 7.50 grams means is that means we lost the gold. So sometimes if it is increases, so sometimes for because of 8, if, instead of 8 grams, if it is source 8.50 grams means the jewelry shop owners will lose their gold. So this is the difference between these standards. So whether it is going low means we lost our money. If it is goes high means people shop owners lost about this gold. So there is some standard and mistakes also will come. But yeah, according to primary standards, the devices would be kept in very safety manner, so it won't show any wrong reading. So it will show perfect reading, but all people can't have that kind of perfect readings. So it will be an protected way. So for that only in a jewelry shop they are using that the meters, the kg weight meters they are using very safety manner. They will keep it, but in according to in vegetable shop they won't keep the weight meters in that kind of safety measures. Just they will put it in front of you. They will use it in front of you. They will use it. So this is the problem in generally we are facing. For example, for a load cell is calibrated using NIST certified weights ranging from 1 kg to 100 kg. But we can't expect that kind of perfect weight. It may be an 1 kg means because of that it will be a zero standard. 1 kg means it may show 950 gram. Otherwise, if it goes, it may show above means 1.1 gram resource means what will happen? 1.1 gram means the shop owner will lose the amount. So this is the problem. I am expecting it to you. Next, calibration of temperature sensors. What is the calibration of temperature sensors? Temperature sensors in thermocouples and RTDs. What are the methods are used? Ice point calibration. Use an ice water mixer for 0 degrees Celsius as a reference. Actually, there are three kind of calibration is there. Ice point calibration means using an ice water mixer as a reference. So the device which we are use the sensor, if it shows perfectly the 0 degrees Celsius means in ice point means ice water means it will be an perfect. In boiling point calibration, if you are going to use, if you are apply the sensor in boiling water means actually particularly I would like to say the temperature only. Okay, thermocouples and RTDs has to show the temperature sensors has to show if it is 0 degrees Celsius as a reference means it will be imperfect. And the another one is in boiling point calibration, if it is shows 100 degrees Celsius means it will be a perfect one. And next to that one is dry block calibrators, devices that provide stable temperatures without liquids. So that what it means, devices that provide stable temperatures without liquids. So here means it has to be so the readings 100 degrees Celsius means it has to always it has to show 100 degrees Celsius and always. If each time if you are putting in a boiling water means it has to show 100 degrees Celsius. Sometimes it is shows 98 degrees Celsius. Sometimes it shows 101 degrees Celsius. Otherwise, it is shows 102 degrees Celsius means it wouldn't be in good readings. So we have to measure everything in a perfect way and calibrate way. So for that only we have to use these calibrate meters. Next one is, for example, for this one is an RTD is placed in a dry block calibrator set to 50 degrees Celsius if its reading is compared to the calibrator's display and adjustments are made if needed. So these are some examples I am telling to you. Next one is pressure sensor calibration. For pressure sensor, there are three kind of methods are using: dead weight tester, pressure comparator, digital pressure calibrator. Dead weight tester means it applies precise force using the calibrated weight. Calibrated weight means already it will be a measured weight. Okay, so if it is if it shows the precise force on that one means it will be a perfect one. Next, pressure comparators compares the sensor output to a known pressure source. And the next one is digital pressure calibrator. This is an latest one. Digital pressure they are using recently. Digital pressure calibrator provides a digital reference for a quick and accurate calibration. For example, a pressure transducer used in aircraft is tested with a deadweight tester. The sensor readings are compared to the force applied. So adjustment made to minimize the errors. Next, actually, this kind of there will be an adjustment things will be there in the sensor. So we can modify the based on the readings. We have to just modify that one. So these calibration measures has to be standardized and use it in every day. Next, force and load cell sensor calibration. There are three methods are used in load cell sensor calibration. First one is applying known weights to check sensor output. Applying known weight to check sensor output. Next, dynamic calibration, and the third one is zero balance calibration. So dynamic calibration testing the sensors respond to changing the loads. So zero balance calibration ensuring the sensor reads zero when no load is applied. Example, a load cell in a packaging machine is calibrated using weights from 1 kg to 50 kg. The sensor's output is adjusted so that its readings match the applied weights within a specified tolerance. So what it means, in dynamic calibration, static calibration means known weights has to be checked. In dynamic calibration means dynamic changes in loads. So first thing, static calibration means only one weight only it will be applied. Next, what will happen means they will change the loads each and every 5 minutes, 10 minutes, or different places also they will put it. Different place means we can check it in India or Japan or America, wherever we go. This we are taking these sensors means it has to show the same reading because geographical based upon the geographical way this has to be this the sensor shouldn't be changed, particularly the sensor shouldn't be changed according to the various places. So next is zero balance calibration, ensuring the sensor reads zero when no load is applied. So this is also a very must calibrated method. So the sensor has to read, the sensor has to show zero. So for example, a load cell in a packaging machine is calibrated using weights from 1 kg to 50 kg. The sensor's output is adjusted so that its readings match the applied weights within the specific tolerance. That here I have marked this as the tolerance means within the readings. If it is 1 kg means below 99.99, actually 999 grams means doesn't matter. If it is 1001 grams means it wouldn't be an acceptable range. So if it is goes beyond that, like at 1010 grams or below it shows 980 grams means it wouldn't be an acceptable range. So for that only the specified tolerance also has to be checked. So before this kind of readings happen means we have to do this kind of checks. Next one is flow sensor calibration in liquid and gas systems. There are three types of calibration are used. First one is gravimetric calibration, volumetric calibration, and comparison calibration. First one is gravimetric calibration, measuring the mass of liquid collected over time. So measuring the mass, how much mass is there. According to the time, it has to be calculated. Next one is volumetric calibration, measuring the volume of liquid collected over the time. This is according to this, how much volume there has been collected over the time. It's also checked. It must be checked. And a comparison of calibration. comparing the sensor's readings to a reference flow meter. Comparison, how they are comparing this one. The sensor readings to a reference flow meter, it will be compared. So its calibrated has been compared to the reference flow meter. For how it has been happened means a flow meter in a water treatment plant is calibrated by collecting water and the container for 1 minute. The container's weight is compared to the sensor's flow reading to ensure the accuracy. So this is for 1 minute, not only 1 minute, 2 minutes, 3 minutes, 5 minutes, 10 minutes. They will continually check about this kind of flow meters readings. So that we can accurately calculate how it has been sensed correctly or wrong. So through this one, we can understand whether it is perfectly done or not.
Participants kindly mute. The network glitch is there.
Next, optical and light sensor calibration for accurate measurements. Light source calibration. Using a light calibrated light source with a known intensity. Mostly the calibration done based on the reference value. But each reference values has some standard, and that meter, that reference values must be calibrated with them national level standards. Actually, secondary standards. That secondary standards has been compared to the primary standards. So the accurate value means where the accurate value will be there means there will be then primary standards. So this will be kept. The primary standards means that kind of devices will be kept in a place, in a very safe place, where we are particularly in underground. They will maintain an underground place. So because why they are maintaining in underground means for an I would like to explain about that one. For an 1 kg weight, for a 1 kg weight, that 1 kg weight won't be an 1 kg weight like that. Because why I am telling to you this means it will be changed to depends upon the time. So actually what will happen means yeah, for 100 years means 1 kg weight can't be an 1 kg weight. It will be changed to an below some amount of weight which will go from that one. So how it will go down means because of the time it will be it will destroy itself. So because of that, mass will reduce. So this is over time what will happen means automatically it will be deconstruct itself. So this is the problem. So for that only we can't touch. Actually the 1 kg weight means we shouldn't touch that one also. So this is the problem with that one. So but we can't we can neglect that will be a negligible value, very small value will be there. So we can't understand about that one because very low weight only will go over the time. So 1 kg weight means if it loss is below 0.001 gram means we won't worry about that one. If it is goes 10 gram 20 gram means we will worry about that one. But according to primary standards means they have to maintain perfectly the 1 kg weight means must be 1 kg weight. It shouldn't go below even 0.001 gram means also they won't accept. But according to secondary standard and third standard, the like working standard means they won't worry about that kind of things. So people always think about that one. So if it is 1 or 2 gram losses means they won't worry. But according to gold value means 8 gram gold means they won't allow the below 1 gram also they won't accept because 1 gram means that will be an 5,000 or 8,000 this kind of values will be there. In future it may go 10,000 20,000 also per gold. So why we go to calibrated readings and values means This is the problem. So where we are applying, where we are using these values. So we shouldn't go below a particular point. So for that only we have to maintain. For our body, pressure must be 120/80 must be maintained. So, but if it is goes above that one means 130/90 means 140/90 means people no need to worry. But if it is goes above 150/90, 160/90 means definitely it will be considered, and we have to monitored and by the doctors, and we have to use the medicines. So like that also in our day-to-day life also we have to check everything must be, everything will be an certain values, certain maintenance, we have to maintain certain standards. For that only each and every sensors also must be calibrated and everything must be in a standard way. So this also has some protocols. I will explain that one later. Next one is testing calibration and proximity motion sensors. So there are a lot of sensors is also there, and their values also has been changed. So how to calibrate means the methods also, different kind of methods also used with that. So here we are seeing distance calibration, sensitivity calibration, angle calibration. So these calibration methods are used for the proximity and motion sensors. First one is placing objects. In distance calibration is used here, placing objects at known distances and comparing the sensor readings. Second one is sensitivity calibration, adjusting the sensor's sensitivity to detect the smaller objects. So it is actually whether it is we have to use small objects. So if this small objects moves means whether it device identify that one or not. Whether sometimes it may slower the, if it is very slowly moves means it has to identify. So sensor has to be identified, but we don't know whether this perfectly works or not. We don't know. So if it is works perfectly means if it is works well, we can say. Next, angle calibration also used in different angles also they are using. So for example, an ultrasonic proximity sensor used in a robot tested by placing a metal plate at a distance of 10 centimeter to 100 centimeter. So this is I am telling it to you how they are testing, how they are testing that proximity motion sensors. So from that particular distance, whether it is showing the right distance or not. So the sensor's output is adjusted. So after that, what will happen means sensor, if it is shows to the wrong reading means the sensor's output is adjusted so that it accurately measures each distance. Next, accelerometer calibration for vibration and motion sensing. So static calibration, dynamic calibration, three-axis calibration is used. For the static calibration, they are using the reference value 9.8 meter per second, meter per square, and dynamic calibration applying known vibrations using a vibration platform. Three-axis calibration, they are using three-axis calibration means there are three directions, X, Y, Z. In each directions, so they will check it, the motion. They will check the motion. An accelerometer in each car's airbag system is calibrated by placing it on a vibration platform. The platform vibrates at a different frequencies, and sensor output is compared to the platform's known acceleration. How much acceleration is has been done? It has been measured by these accelerometers. Next, environmental factors affecting the sensor calibration. How the sensor affected by the environmental factors. First one is temperature, another one is humidity, and the third one is pressure. So these, if it is these are the main things. Temperature increases means electrical properties it will affect the sensors also, sensor readings. The third one is pressure. The pressure also affects the is sensor by or by force. So pressure means pressure is applied continuously means it will affect its readings also. These are the three things. And next, automated calibration system advantages and challenges. For example, a semi calibration because of high cost, so he has to do many accuracy. For that only we are using this kind of value automated calibration system. And the challenges is calibration of wireless sensors. Here there are three network calibrations. The network calibration in the data transfer is this method. Measurement accuracy. Types of zero error, span error, and identity error. The sensor doesn't read the first thing is zero error. Zero error, the sensor doesn't read the zero. This is a is present. Next, span error. Span sensor's response is incorrect at a specific input value. If you are giving over 5 or 6 means it has to show the readings 5 and 6 in their readings. So particularly we can say or ammeter or voltmeter if you are taking means it has to show the 5 volt or 10 volt. It has to show perfectly. 5 amps, 10 amps means it has to show perfectly. But if it is don't do that one means it is a span error. Next, linearity error. The sensor's output doesn't increase proportionally with the input. The sensor's output the voltage in the out. Next, for example, you have blood pressure monitor for medical diagnosis means it wouldn't be an monitor testing and protocols test. There will be accuracy test. First thing is comparing sensor readings to a node. Celsius means also show the already the durability test, testing the sensor's performance under extreme conditions. So under extreme conditions means whether it is can be used for an in normal places. Otherwise, next it will be placed in high altitude places. High altitude means we have to go for similar traveling with this kind of places. So for on that places, what will happen means so if you are going for Himachal Pradesh means if you are going Himachal Pradesh means it will be a there will be higher the temperature will be very low. So in that places also it has to work. If you are going for desert places means the temperature will be very very high. So in that places also it has to show the same readings. So if you have so each in different kind of places means if it shows different kind of readings means it will be a good one. So for that only we have to do this kind of durability test. Thank you for patience.
So, good evening, participants. So, do you have any queries? If you have any queries, you can post it in the chat box. Participants, if you have any queries, you can post it in the chat box. Participants, do you have any queries? Okay. Okay, thank you, ma'am. So, the next session will start by 5 p.m. and the participants are requested to stay in the line. Thank you. So again, warm welcome to all participants. So once again, the session is going to be held by Dr. K. Karthikeyan, Professor, St.Mother Theresa Engineering College, and I directly hand over the session to him. Thank you.
This is my second presentation. Case studies in sensor industrial applications. Why we have to why we are going for the case studies means how the industries are using their sensors to their real-time applications and what are the problems they faced in their day-to-day works. So has been analyzed in this session. So now I will show it to you 20 case studies has been analyzed and I have shown it to you. So first thing is vibration sensors for General Motors, how they are used. And the second one is IoT sensors, Siemens company used. And temperature sensors, Dow Chemical. And smart energy sensors, Schneider Electric. And pressure sensors, Caterpillar. So I have shown it to you 5 sensors. How the sensor has been used by these companies, in which kind of situation they faced. So now I am showing to you vibration sensors in General Motors. General Motors uses vibration sensors to motor machinery vibrations. So here the machinery vibrations will be more. Actually, lot of works will be done. Because of that, in General Motors used to make the cars. So in their factories means many motors will be there and the vibrations also will be there. So how the vibrations affects their work, so we have to understand that one. So for this only we can see the problem statement. The frequent equipment breakdowns happened because of the vibrations. So equipment breakdown means say quickly the equipments destroyed and breakdowns. So because of this only they face the production delays and the increased maintenance cost has been increased. So for that only they want to avoid the vibrations to a particular limit. So only they used that vibration sensors. So vibration sensor we were installed on motors and the conveyors to detect the abnormal vibrations. So the abnormal vibrations when they will happen means because of that overloadings and because of the current and voltage violations, limit violations means happens means, so faulty equipments also will do like that only. So abnormal vibrations may come because of these reasons. So we have to avoid this one means, first they have to identify the proper vibrations. So for that only they use the vibration sensors. So they has been applied on motors and conveyors. So now the result, how they got the result means, after installing the vibration sensors, 20% reduction in unplanned downtime. So maintenance cost also lowered 15% and improved production efficiency and equipment. So vibrations is a very important thing day-to-day life also. So vibrations, where the vibrations you may see means, if you are going in a bus, so it will also daily if you are going means you will face that kind of vibrations in your buses. So 1 or 2 days means you won't face that one. So when you will face this kind of vibrations means, if you are daily going by bus means the bus, you will feel the vibrations in the buses. So if it is going beyond one particular limit, means what will happen? Automatically, the equipments will damage and it will go very soon. So to avoid that one, we have to identify where the vibration comes, where which equipment gives this kind of vibrations has to be identified, and that will be modified, monitored daily and weekly and violations if this goes beyond that maintenance. Next one is IoT sensors used in Siemens. Siemens IoT sensor enables smart factories to monitor machines. So on what the problem they face? Why they have to use the IoT sensors? So lack of real-time data to slow the response to equipment issues and causing delays and higher costs. Real-time data, why they need the real-time data means, when usually they are monitoring their systems. So if they are monitoring daily systems means, slow responses as they are facing. So real-time data means real-time slow responses has come because before the IoT sensor, what are the things they used? Many type of sensor they used. So they that kind of sensors are manual sensors, and daily they have to watch that one and they have to write it down. So if you are doing like this means, it's a manually, if you are doing means there can be a manual errors also can come. So to avoid that one, they use the IoT sensors. So this is avoid the delays. So and this kind of delays, if they are avoid the delays means, they can face a very uh, naturally, they are avoiding the delays means they can naturally get the real-time data very quickly, and they can take decision. So for that only they used applied the IoT sensors. So their IoT sensor particularly deployed to collect the performance data and enabling remote diagnostics and predictive maintenance. So in remote diagnostics means one person is managed, particularly manager sitting in his room, can check whether all the works are going perfectly. Means they can monitor through this laptop or the device, desktop devices. They can monitor very quickly. So any abnormal conditions, if we see means, they can quickly make decisions. So for this only, these IoT sensors are applied in smart factories. So this is this gives uh, advanced this will be gives an advanced positions to these kind of smart factories. So for this only they saw the results: 25% increase in equipment uptime, 18% reduction in operational costs, enhanced production speed and quality. Also, next one is temperature sensors in Dow Chemical. Dow Chemical uses temperature sensors to maintain the precise control over the chemical process, ensuring quality and safety. So temperature sensors, if it is chemical added in a factory means shouldn't be exceed that one limit. So continuously, if you are working means, so the equipments will be heated up. So the heat if increases means particular beyond the particular limit means it will the chemical reaction will change the its equipments. Actually, Dow chemicals means they may use many kind of chemicals to make the soaps or any other things. So for that only they are monitor. They have to continuously monitor the mixing reactions in between the chemicals. So this will make their chemicals and their particularly their components. Particularly their components. So if it is heated up more means it will change their chemicals position and unexpected damages. It shouldn't come to their equipments. For that only they are would like to install the temperature sensors. So, yeah, particularly the problem statements means inconsistent temperatures led to product defects and safety risk. So, temperatures varies means actually particularly in their equipments for particularly chemicals. Chemical temperature varies means temperature they have to maintain certain temperature. So then certain temperature means it shouldn't be 50 degrees Celsius, 60 degrees Celsius means it has to be maintained in a particular way. So if it shouldn't be go beyond that particular limit means it will be maintained on quality. So if it is goes beyond one particular limit, if they are would like to maintain 50 degrees Celsius, means if it is goes beyond 60 degrees, 70 degree means the product will change its position and unexpected results also they will come. So to avoid that one, they are to maintain the proper temperature in their chemicals. For that only they are using these temperature sensors in their production lines to continuously monitor and adjust the process temperatures. So this gives the results of 30% reduction in product defects and it has been detected and enhanced process stability and safety also. So overall, it increases energy efficiency also. And next one is smart energy sensors in standard electric has been used in where they will apply this smart energy sensors. Why they used this energy sensors? So why they need it? So well, let us check. Problem statement means here high energy consumption and lack of visibility into energy used to increased operational costs. Because high energy consumption, where it has been there, they have to identify first. In standard electric means they have to identify they are producing the product, the MCPs, the circuit breakers, and other many electrical oriented equipments they are producing. So they have to check whether which max the problem, which max the higher energy consumption means which takes more too much of energy. They have to identify. If it is in which equipment has been took too much of energy means they have to identify and they have to replace with that one. Particularly in our houses, we are using the tube lights and the fans also. If we are using the LED bulbs and VLDC motors means we would save the energy. So like that, they have to identify the places where the energy is a lot of energy is consumed. They have to identify that one. So for that only they use the smart energy meters. The smart energy sensor they have used in their energy management systems to track and optimize energy consumption. So this gives the result 20% reduction in energy cost and improved energy efficiency and sustainability. So overall, energy regulations and efficiency they are using this kind of energy meters. Next one is pressure sensors used in Caterpillar. Caterpillar uses pressure sensors in hydraulic equipments to ensure optimal pressure levels and system performance. problem segment. Fluctuating pressure levels cause the equipment malfunction, reduced performance. So here actually Caterpillar uses many kind of equipments, particularly for they are using that they have to apply the pressure and take the weights. So Caterpillar uses for weight lifters that kind of equipment they are using. So applying pressure means it has to be maintained particular level. It shouldn't go beyond the particular pressure level. If it is goes beyond the pressure level means it wouldn't give optimized performance. It wouldn't give a perfect performance. So for that also they are avoiding that one. To avoid that one, so they have to use the pressure sensors. So perfect pressures has to be applied. They have to monitor each and every time what will happen means, and they finally they have to decide where to tune the pressure levels. For that only they are using these pressure sensors. So pressure sensors were embedded in hydraulic systems. So next what will happen means 15% increase in equipment reliability, reduced maintenance costs also. So thus it makes improved operational efficiency made by the Caterpillar. Next, wait a minute. And this is will be a next batch. Next one is level sensors, Coca-Cola. Coca-Cola uses level sensors to monitor the liquid level. So in their storage tanks to ensure its efficient production and supply chain management. What happens means level monitoring was time consuming and prone to errors because each time level monitoring in their product means Coca-Cola means that you know very well they are producing many kind of beverages and continuously they have to monitor how much level they have to maintain to produce a new Coca-Cola product means each time they have to find out what is the level is there and the perfect consumption. So for that only they have to continuously monitor it. But if they are using manual power means it will be totally affect their work. So for that only they applied that automated level sensors were installed in their storage tanks to provide real-time level measurements and prevent stock shortages. So uh, For that only, they increased their production. So after the installation of the level monitoring devices, they have increased their production and they improved the management, inventory management, and they reduced the manual labor and errors also. So manually, the very many kind of errors will come. If we are checking means sometimes they may say they may wrongly they may identify the levels. So these kind of levels are at the time of starting of the production of the Coca-Cola company. They face the error. But nowadays they apply the automatic level detectors, accurately find the levels, and if they are going to produce new kind of Coca-Cola or a new kind of beverages means it will be very useful for that. So for this kind of the efficient operations, they are using this level monitoring. Next, gas sensors in cell company. How the cell company uses the gas sensors in their workplace. Now see, Shell employs gas sensor in its oil refineries to detect hazardous gas and ensure compliance with the safety regulations. What happens? Let us see. Undetected gas leaks pose to safety risks because sometimes gas in their oil refineries means lot of oil will be saved. Actually, what the cell do in India means they are selling the petrol and diesel also, and many kind of petroleum related products they are selling. So if any gas leakage comes means the next they will lead to unwanted uh, chemical reaction, and it will make to very easily their damage their products. So particularly the petrol diesel means their containers, everything would be get damaged because of their unwanted gas leaks. So to detect the gas leaks before they are forming means they have to use this kind of gas detectors. They have to use it. So for this, the gas sensors has been applied in critical areas, not in all areas where the gas leaks would come. They are expecting means that in that places only they apply the gas sensors. So thus they monitor the sensors and apply the triggers alarms also. So if this gas goes beyond a certain limit means it will give an alarm and make the people alert. So now they approved that one. Enhanced workplace safety. They have increased the workplace safety, reduced the risk of gas-related incidents, and improved regulatory compliance. Next one is position sensors used in Tesla. How the Tesla apply the position sensors in their workplaces, on what basis? Why they are using the position sensors? Tesla use the position sensor means robotic assembly because Tesla not only use nowadays many factories use robotic process only. They use robots to do their manufacturing the cars. So what happens where they apply and why they apply the position sensors? Let us see. Misalignment during assembly caused production defects in the rework. Position sensors means where the alignment. So position means particularly where it has to be fixed. The car is there means it has to be doors also is there. So front doors and back doors, everything has to be perfectly assembled. Perfectly assembled and it has to be fixed. So where if it is any misplace happens means it will totally damage the equipment and totally it will stop the production of the cars. So to avoid that one, they have to use the position sensors. So where they will apply position sensors were integrated into the robotic arms. They applied it robotic arms and guide the accurate component placement. Where they have to install the components means they perfectly and accurately it will apply that component in that places. So thus they will avoid the misalignment. Particularly, I want to say the misalignment. They avoid misalignment through the position sensors. So now, after the applying the position sensor, 15% reduction in production defects. They they saw, and increased assembly speed also has been increased, enhanced product quality also they saw, and consistently it happens. Next, optical sensors in Samsung company. How the optical sensors used in Samsung company? Let us see. Samsung utilizes optical sensor to detect the defects in semiconductor manufacturing. Semiconductor manufacturing, they are inside semiconductor manufacturing. They are using. Actually, Samsung uses many kind of devices, electronic oriented devices. They are using that you know very well. That you know, Samsung is known for their cell phones, TVs, fridges, and washing machines also nowadays. For televisions, particularly, not only televisions, but they are using particularly known for the Samsung mobile phones. So in their devices, semiconductors are very very important. So where what kind of problems they faced, where they apply the optical sensors. Let us see. In problem statement, manual inspection methods were slow and prone to human error, so impacting product quality. So inspection that has to be whether it is being properly embedded or not. So they have to check. So for that only manual inspection may do the errors. So to avoid that one, they use the optical sensors to inspect the wafers. So wafers means they are continuously they have to apply one devices. That means next to that one they have to apply the layer by layer. They have to apply the other parts of the equipments. So for that only this shouldn't be misaligned. So for that only they are using the optical sensors to avoid the defects. So thus it reduces a 25% reduction in defect rates and faster production cycles and improved their reliability. So this is the main thing. Next one is proximity sensors in Amazon. How the proximity sensors used in Amazon? Let us see. Amazon uses the proximity sensors in its automated warehouses to guide robots and prevent collisions. So what is the problem they faced? Robotic collisions and navigation errors slowed down and order fulfillment and costly equipment damage. So robotic collisions means robotic continuously collied in their places. They couldn't navigate properly. They where they have to go, and they shouldn't collide with the other robots. So because of that, it has to be perfectly they have to move. So make that also the proximity sensors has been installed on robots to detect nearby objects. Proximity sensors used to identify the objects which is being nearby. So because of that, robots has been identified the nearby objects. Next, they move without any collision and perfectly they navigate their paths and they do the works. So this is the advanced things. They are using the proximity sensors and they use it in their robots, and they get the results of 30% increase in order fulfillment speed, reduced equipment damage, and enhanced workplace safety also. Next one is load sensors used in Boeing. What happens in the load sensors and in Boeing? Boeing that you know very well, it's an aircraft manufacturers in the world, leading aircraft manufacturer in the world. Their approach is very very different, and their aircrafts are being everywhere. They are particularly passenger aircrafts they are manufacturing, and they also made the war aircrafts also they are selling in worldwide, but particularly they are known for their aircraft, passenger aircraft only. So how the load sensors are used in the Boeing, in what kind of situation they use the load sensors? So what the load sensors used in that means to measure the weight of the aircraft components. So compliance with weight specifications actually that you know very well. Yeah, if there is a lift in a mall means it has to bear the particular weight only. So particularly means it can weight and lift can bear 1000 kg, 2000 kg weight only means only it can lift the people from ground floor to top floor. It will take it. So they will mention in each lift, they will mention 10%, 1500 kgs only, like that they will mention. If it is goes beyond that limit means it won't lift. So for that only they use some sensors, and it will monitor, and it will give the signal to the people. If it is beyond the limit, please it can't move, like that it will show. So because after that the people will get down. So a particular 10 people means 10 people only will go from ground floor to top floor, they will go. So like that, in flight also, in particular weight also is there. So the machines will take one particular weight only. So if this goes beyond particular weight means the flight can't take. So for that only they using the load sensors, where incorrect components, actually according to the problem set means incorrect common weights lead to balance issues and safety also. So this will be great problem in aircrafts. So load sensors were integrated into assembly lines. So to accurately measure and monitor the component weights, each weight has to be fitted perfectly before that assembled. So this is the main thing. So thus they give the results of improved weight accuracy and enhanced the aircraft safety, also reduced rework and delays. So if it is if they're done without using the load sensors means they have to rework, and the work also everything will be delayed. For that only they avoid. If they want to avoid means they must do that one perfectly. So next, humidity sensors. How Fisher used the humidity sensors in their workplace. Fisher employs humidity sensors to maintain a precise humidity levels in their pharmaceutical production facilities. How the humidity sensor has used, and why they are used? Let us see. Excessive humidity compromised product quality and stability. Humidity sensors were installed in continuously monitor and control humidity levels within production environments. So Fisher, known for the uh, they're known by their pharmaceuticals. Actually, they produce the uh, medical devices, and also they produce the medicines. Particularly, they are producing medicines. So if it is a humidity level increases means what will happen means their product will change their position. So if it is modified products means actually it will give the side effects in their if the humans consume that one means that will make different kind of side effects in their medicines, and it will applied in there. It will be consumed. If it is consumed by the human means it will be negative side effects. So to avoid that one, they use the humidity sensors, and in the results it is 20% reduction in product defects. They avoid 20% reduction in product defects, and enhanced product stability also has been improved. Thus they improve their regulatory compliance. Next, infrared sensors, accelerometer. So how the accelerometer uses the infrared sensors, and where they applied that one. So as an accelerometer produces the steel, how the infrared sensors used where used their sensors. So manual temperature measurements were slow and inconsistent, affecting their product quality. Actually, what the accelerometer uses produce means steel. They are producing the steel. So the temperature measurements being perfect means they can make perfect steels for their products, and the different kind of their steels they are producing. So each needs different kind of temperature readings. So perfectly to produce the particular equipment means steel product means they have to know what is the temperatures. So say use the infrared sensors in their devices, and provides perfect data, real-time data to them. So they produce the steels in a very efficient manner. Thus, it results 50% improvement in product consistency and faster production cycles also. So this also overall has been improved their efficiency. Next, acoustic sensors in BP. BP utilizes acoustic sensors to detect leaks in their oil pipelines. Actually, you know very well, BP means Bharat Petroleum. Bharat Petroleum produces the petroleum-related products. So, to the what kind of products they paste and where the acoustic sensors has been used. Let us see. They saw that leaks in their pipelines. So it is being undetected leaks, fast environmental hazards and regulatory violations also. They actually their petroleum products should be spilled in anywhere places. If it is spilled, means it will make environmental impacts and affects the particular area. So to avoid that one, they have to identify the leaks. So what they use mean acoustic sensor has been installed along the pipelines also to detect the sound patterns and associated with the leaks they are used. So now they have improved their products, their detection. Faster leak detection has been identified and reduced environmental impact also were there and improved regulatory compliance. Next, wireless sensor networks. Wireless sensor networks now the Bose company uses. Bose company uses wireless sensor networks to monitor machinery and optimize production process Industry 4.0 initiatives. That you know very well. Industry 5.0 is also coming. Industry 4.0 has been still is going on, but in only in well-grown countries like European and America also and China also they are being there. But Industry 5.0 is also coming. Industry 4.0 means fully automation. Industry 5.0 means one part they are using the humans also in their workplaces. They are using the cobots also. Cobots means collaborative bots. For Industry 4.0, only machines also will be there in the industry. Industry 5.0, they use humans in their workplace to make well works because Industry 4.0 also is not practiced in all over the world because of the high cost. They don't use it. So to avoid that one, Industry 5.0, they use the humans also in their workplace. They don't avoid the humans. So in the workplace, they are using cobots means uh, they try to spread it. They try to spread the robots all over the world. So thus they reduce the um, production cost. Just they reduce the production cost means reduce the inefficiency because if it is only humans are there means it will be a good production. There will be a production will be very less. If they are only using robots means if there are no humans means there will be no humanity means their production wouldn't reach an right place. Thus, it will cause to negative vibrations only will be there. So, to avoid that one, they go for the Industry 5.0. So, in Industry 4.0, what happens means Bose company faces this kind of problem. What the problems they face means limited scalability and increased installation cost they face. So, in wired sensors, they face the limited scalability. When particular places only they can monitor. So they go for the wireless systems. So wireless sensor networks also they used. So wireless sensor monitor machinery and optimize the production process very easily. So because of that, this kind of wireless sensor networks collect the real-time data and used for the remote monitoring systems. So it results 20% increase in production efficiency and reduced maintenance cost and enhanced operational flexibility. Next one is uh, ultrasonic sensors and BASF used and dark sensors, BMW, flow sensor in Nestle, flow sensor in ABB, LIDAR sensors, Toyota. How they are using these sensors? First, we see ultrasonic sensors in BASF. BASF uses ultrasonic sensors to monitor tank levels and chemical storage. So to monitor why they what happened to them means first according to the problem statement, manual level monitoring was done in that places. So because of that, what happens means it shows inaccurate and post security results. So to avoid that one, they use ultrasonic sensors to measure the right liquid levels in their storage places. So and also it provides the real-time data. So because of that, what happens means improved safety and accuracy also done and reduced manual checks also were there. Because of that, enhanced inventory management also they give. Next, torque sensors in BMW. How why BMW apply the torque sensors and how it will benefits to the BMW. BMW employs torque sensors in automatic assembly lines to ensure bolts and fasteners are tightened properly or not. So incorrect torque levels. So incorrect torque means what torque means? Torque is a force, particular force. So particular force it is applied means everything nut and bolts has to be applied and it has to be tightened properly. Then only the torque will come. So right torque will come in their assembly lines. So to avoid that one, they apply the torque sensors were integrated into the assembly tools. So the assembly tools monitor monitored by the torque sensors and the tightening force also being in the rating force also is being there in the right places and right places it has been applied. Now they can show the real-time data and their workplaces and nothing boards has been do their work properly. So thus it results in reduced assembly defects. So particularly they used it in assembly line. So it reduces the assembly defects and enhanced vehicle reliability and improved production efficiency also. Next one is flow sensors in Nestle. How the Nestle company uses the flow sensors and where they applied. Let us see. Nestle uses the flow sensor to optimize water usage in food processing plants, supporting sustainability goals. So excessive water usage in Nestle company actually you know very well Nestle company produces many various kind of food products, particularly chocolates and dairy products also they are producing it that you know very well. So they have to check the water level and the liquid level. Everything has to be properly maintained. Actually there shouldn't be any chemical reactions that you know very well. Chemical reactions shouldn't be there. So to avoid that one, say excess water has to be used. So they are in their workplace. So to avoid that one, flow sensors they were installed in their water pipelines to monitor the consumption and the detect leakages also. Detect leakages are also identified and it has been reduced. So finally, what happened means 15% reduction in the water consumption, lower production cost also happened, and improved environmental sustainability also they maintained. Next one is force sensors in ABB. How the force sensors has been used in ABB, how it benefits to them. So ABB integrates force sensors into the robotic gripplers and to enable precise handling of delicate components in collaborative robotics. So what happened means excessive gripping force has been damaged the fragile components. So the gripping has to be applied proper way so to avoid the damages and also reducing the production yield. It also do. So for that only they apply the force sensors which has been embedded in robotic grippers to adjust the force based on the component sensitivity. So because of that they reduce the component damage, increase their production yield, and enhance robot versatility. Next, lidar sensors. How the Toyota apply the lidar sensors in the workplace and for what? And let's see. Toyota utilizes lidar sensors in automated guided vehicles to enable safe and efficient navigation in smart factories. So, what happens means automated AGVs, they face the navigation errors. Actually, what is this one means? Automated guided vehicles. This way we say that is, AGVs means automated guided vehicles. Navigation errors will become, and this has to be coded with the other devices, other vehicles shouldn't be coded. For that also, they use this lidar sensors. So lidar sensors were added to the AGVs to create 3D maps of the surroundings and avoid the obstacles. Thus, they improved the AGV navigation and safety, increased production efficiency also, reduced downtime and collisions also. Okay. Now I give it to you two papers to you to understand the case studies, how the case studies has been done by the company, and how it has been benefited to their workplace. So I will give it to you the two papers to you to you have to work out with that one and say the results, how it has been give the benefits to the particular workplace. Now I have given 20 case studies. I have given to you 20 case studies to you how the sensors has been used in industries, how has been given the benefits to them. This has to be uh, this has to be for your understandings. How the sensors has been used in these industries, how it has been benefits to them. So now now I give to you the two papers. Now you do work out. Okay, the papers will be shared and I do the workout.
My dear participants, one kind information to in both WhatsApp groups, two journal papers have been posted. So all participants must submit the review and mail it to the mail ID mentioned, that is ecehod@mtec.ac.in. You have to submit the review paper and you have to analyze the paper and submit the review by tomorrow evening. So kindly submit the same. Right, okay, thank you. Participants, one another kind information, the assessment questions will be posted in the WhatsApp group shortly, and all of you have to complete the test before 7 p.m. At 7 p.m. all are requested to join the session in which valedictory function will be organized and a group photo will be taken. So thank you. Kindly cooperate with us. Thank you. Now feedback will be posted at the time of valedictory function. Okay, thank you. We are going to post the test link in the WhatsApp group.